I think my abbreviated topic will be as follows: climate smart and resilient agriculture adaptation. And we will explore this option. And I will just discuss brief and some of the elements part of this, especially on the ground level, because that's where, let's say, the tacky hit the dust at the moment, on the ground with the farmers. I just want to show this, start with this slide as a kind of a link up with the previous speaker and the previous sessions. And I'm sure you're all familiar with that. This is the climate change predictions, this is our current path. You realize by now that this is a dangerous path. And in order to meet our goals, Paris goals and obligations and targets, we need to bend down this curve right down into net negative global emissions. And for that, we really need drastic measures in all the sectors, including agriculture. And that is the message from the previous sessions as well as the previous speaker. And that's where I want to start. The good news is that agriculture can reduce carbon footprint, its carbon footprint. It can draw down carbon, and it can cool down Earth by regenerating the natural biosystem, by regenerating or restoring nature. That's the good news. And that's the most practical solution that we have in our hands, in the farmer's hands, and all of us hands, and beneath our feet, in the soil. So the soil is the heart of the system and the solution. Because if you take care of the soil, it will take care of you. That's one guarantee in this whole debate that we really need to realize. But we need to better understand soil and how to put that life back into the soil which has been depleted, how to restore soils. That's really what we really need to do, and that's what I'm going to talk about. So that is soil, and that is a living ecosystem. It's full of life. 95% of life on land is in the soil. 1 teaspoon of soil has more living creatures than people on Earth. All right, so there is a lot of life in soil, and that is a direct link and is part of the big solution of climate change. Those are just a couple of the pictures of the creatures that we find in soil: bacteria, fungi, protozoa, nematodes, arthropods. Those are some of the beautiful creatures that we find in trillions in the soil, in 1 teaspoon of soil. And those are the key agents in finding a solution for climate change. Let's see how. First of all, as I said, soil is a living ecosystem. It gets its energy from carbon. That carbon is harvested by plants from the atmosphere through photosynthesis. That's really important because excess carbon is in the atmosphere. That is heating up our Earth. And this is an opportunity to draw back that carbon out of the atmosphere into the soil. That is called carbon sequestration. Into the biggest sink, carbon sink on Earth, and that is soil. But doing that, we feed the zoo beneath our feet, that living ecosystem. We really need to do. We really need to go through the soil food web in order to sequester the carbon. And that is eventually, if we do that, it will restore a lot of soil ecosystem functions and services. A soil sponge will be formed, more water in the soil, cooler earth, cooler landscapes, more fertility, less diseases, and so you can go on. And this is how one of the creatures, is what we call one of the fungi, mycorrhizal fungi, look like. So that mutualistic relationship between roots or plants and microbes is really part of the solution, part of the healthy soil. This creature, the fungi, mycorrhizal fungi, is able to increase root mass by 1,000 times. In 1 square kilometer, there's 25,000 kilometers of hyphae, what we call these root mass structures of mycorrhiza. And that is able to get more water out of the soil, more nutrients out of the minerals, less diseases, etc., etc. So those are the kind of creatures that's going to help us to fight climate change. And this is how a healthy soil looks like. That is what we are trying to achieve. A soil sponge, able to capture much more water, infiltrate, less diseases, more fertility. And of course, agriculture, due to this opportunity we have in agriculture, has a huge abatement potential to sequester carbon from land restoration, livestock management, pasture, cropland management. All the technologies and practices are there. We just need to implement. We just need to find the policies and the mechanisms and the programs to be able to help us to implement it faster and better, work closer towards the farmers. It's also help us, if we put these practices in place, to restore the small water cycle and fight desertification. I think this is it's a factor that is really not emphasized much enough, because we have a lot of open, clear fallow systems in agriculture, overgrazing, tilled soils, compared to that kind of system. And that caused desertification. You all know desertification, I'm not going into detail, but some of the factors that influence desertification is tillage, loss of carbon, bare soil, and those that have positively affected is green plants, the soil carbon, soil cover. And it all has to do with land management, how we manage the land. So this is a really important key short-term solution that we can do with agriculture. The negative side at the moment is we've lost about half of our carbon out of the soil due to the last 50 to 100 years of tillage. So we really need to restore that before we can talk about real solution. We're losing a lot of soil through water erosion. We need to infiltrate the runoff water, capture it in the soil sponge, but at the moment we're losing about 2 to 3 tons of soil per hectare, and that is 13 tons per hectare per year. That is, for every ton of maize we produce, we're losing 2 to 3 tons of soil per year. So that is what's happening with water. We also have a lot of problems with wind erosion, especially in the west. And the big concern here is desertification because of those open fallow systems. Desertification, wind erosion, less chances of precipitation. Coming back to this situation, we really need to move from that situation to that. Immediate impact in the small water cycle, restoring natural biosystems, cooling earth, more rain in the landscape. So, what are the principles and processes of, let's call it conservation agriculture or regenerative agriculture for restoration and adaptation? You've seen some of them already. The first one is, and I'm just talking about mostly crop systems or crop livestock systems. We can go so much further, but the time is limited at the moment. So the first principle is minimum mechanical soil disturbance, because the moment you disturb the soil, you start that trickling down of the soil degradation process. The moment you disturb the soil. We don't want to disturb it, we want to plant into the soil with a no-till planter. There's examples of no-till planters, big ones, smaller ones, animal-operated, hand-operated animal or no-till planters that we can plant without disturbing the soil. The second principle is permanent organic soil cover. Those are pictures of beautifully covered soil planted in a no-till system. You can see the wonderful image there, and the functions of permanent organic soil cover is to protect it from erosion, food for microorganisms, it controls temperatures, it suppresses weeds, and it improves the soil-water balance and has a huge effect on the small water cycle. The following principle is higher biodiversity. That simply means we need more plants, species, and more animals into the system. Because we've lost our natural biodiversity, we need to bring it back. Those are just beautiful pictures of biodiversity in plants. Because remember, we want to maximize the diversity of roots in order to feed this soil food web, the different microbial populations in the soil. We want to have more plants to maximize photosynthesis. And we want to have more plants and animals to maximize carbon sequestration and ecosystem services. For example, the predation from natural insects, fighting diseases, fighting pests. So that is the function of high biodiversity. In cropping system, crop livestock systems, we do that, for example, with multispecie cover crop systems. There's simply specific species with a specific function to build soil, to feed animals, to protect, to suppress weeds, etc., etc. We can have summer and winter, annual and winter crops, and preferably want to include plants from the different functional groups, like legumes, grasses, brassicas, etc., into that mix. We can go up to even 20 different crops into one specific mix to increase that biodiversity in the rotation in the farming system. Those are just pictures how it looks like when it's matured. This is just a summer cover crop mixture in one of our fields in the Free State. The next step we want to do is to integrate livestock, more animals into the system. We want to use these multispecie cover crops with livestock and in a specific manner. And that is by mimicking natural grazing systems. In other words, those big herds of animals that flocked over our natural grazelands, natural veld systems, and built our soils over millenniums of years. That's the kind of system that we want to mimic here. So you can see a big herd of animals. It could be cattle, together with sheep, together with chicken or pigs. The more the better. The more diversity, the better. The bigger the impact on the soil, the bigger the carbon sequestration is. And it's not really a cattle, it's a mobile biodigester. That's the better word for a cow. Right, because the microbiome of the cow is more or less the same than the soil. It's more or less the same as us. But it is the best way and easiest way to replenish the soil food web, the microbial population of the soil through animals and through the right grazing system by moving them over in short time spaces over the land, having that massive impact on the soil health. So at the moment, these kind of systems, let's call it resilient or climate smart crop livestock systems are emerging, and that's what we're trying to develop, and that's what a lot of farmers are already doing, taking the lead in this. This is an example. So you start with 1 year of cash crop, for example, maize. Then you follow that, you rotate that with this biodiverse annual or perennial cover crops plus livestock system. It could be 1 year. It could be a perennial system for 3 to 5 years. And then you follow that and you build the soil much faster here. Of course, this is all no-till. You build the soil much faster there and you follow it up with another cash crop. It could be maize, soya, sunflowers, wherever you are, with whatever you want. And then you follow that up in a very short cycle, bringing in diversity, having a massive impact on the soil, pulling back carbon, restoring the small water cycle. That is what we're trying to achieve here. Okay, so that is the practical system, the technology, the solution. Where are we in terms of farmers in South Africa? This is just a very rough, simple typology system of all our farmers, or different systems in South Africa, specifically cropping systems. You can see that you start with conventional system, you minimize your tillage system, conventional tillage, no-till, and then your zero tillage, and then you have a full conservation agricultural system with all your principles included, but still with high external inputs. And then you move on to conservation agriculture with low external inputs, and then regenerative agricultural systems with organic. You can even move further down to agroforestry. I'm trying to think of the other name, permaculture, etc., etc. You can move further down. Let's stop here for the moment and just discuss the principle. So where are we in terms of adoption? The latest study by Findley showed us that about 80 to 85% of farmers are still around here. I guess most of them are here. About 50 to 20% of crop farmers doing some kind of, or doing conservation agriculture, applying all the principles. But we know we want to bring them here. There's a couple of them on low external input conservation agriculture and a couple of them on regenerative agriculture. That's where we want all of them as quickly as possible, because it's good for them, it's good for the environment, it's good for the climate. But we cannot shoot the farmers who are still hovering around there, because we know that they are doing the best they can in their context with the knowledge, the skills, the funding, the implements, whatever they have. They're doing the best. So there's a different way we need to transform this system, moving farmers quicker to the right. How do we do that? Because that's the question. How do we help farmers to adopt much faster? We know that this linear approach doesn't work, where some scientist is doing some experiment on his station or in his lab, and it's trickling down via the extension officers to the farmer. It doesn't work at all. Especially with complex systems like conservation agriculture, where you want to induce it into another complex system, community. What works is a really interactive approach where researchers, farmers, extension officers, and other farmers are really coming together and interact like we do here in this complex on-farm system. It's called what we call a participatory systems approach. That works very well. This is how complex systems develop and adapt. I'll come back to this. So the elements of this approach, this participatory systems approach to research, development and adaptation, what we form in our program at Grain SA, there's a lot of other elements, but we found these as really the key elements, what we call a farmer-centered innovation platform approach. First of all, on-farm research, because that's where the innovation takes place. That's where the problem is, and that's where the solution needs to take place. It's on-farm, in the community, nowhere else, right? So based on that, we create a lot of awareness. We're creating access to information, education and training from school level, tertiary level, but specifically farmer level. That's where we need to build our knowledge. Then, especially relevant to this discussion, incentives and market-based mechanisms. Key. We haven't addressed that almost at all. There's beautiful tools, incentive tools available that we've developed, waiting for business community to explore, to use, to tap into, to make this thing roll forward much faster. So this innovation platform that is needed for continuous adaptation is looking like this. The innovator farmer in the middle, because the farmers are the innovators here. They are the drivers, nobody else. They've been leading this process, let's say for 10,000 years. That's how old agriculture is. But let's call it 100 years for conservation agriculture. The last 50 to 100 years, innovator farmers are in the lead, 10 to 20 years before anyone else. But we don't want, they will always be in the lead, but we don't want them to stand alone anymore. We want them to be supported by a lot of other stakeholders like us and be stronger and more resilient. So the principles of this is continuous interaction and dialogue, facilitation to bring these people together, on-farm and farmer-centered innovation, experiential and discovery learning. They need to do it, and they learn and adapt by experience, by experiments, and by discovery, and learning by doing. This complexity thing, the best answer for that is just to start doing it, just to start. Otherwise, you will just wait forever and never start doing it. Just in summary, I just want to show you the process. It's an iterative cyclical process of adaptation, participatory systems approach. Start to plan, act. For example, do experiments together. These are the kind of experiments. Then monitor the type of indicators that we use and who are involved. Farmers should be involved. Their experiences, their observations are critical to be part of this monitoring process. There's different indicators that we really need to focus on. Otherwise, we will still go in the wrong direction. And then sit together frequently as possible. Look at our stories, at our experiences, at our observations, our data, and go through a process of dialogue and social learning. Use every opportunity to maximize interaction and learning with farmers and stakeholders to refine and adapt in groups supported by better data, experiences, and stories. And then farmers go out and they do, and they adapt, and they change their practices. And that's the only way that we can do this. And the stronger this process, the more vigorous, and the better we scale it out and scale it up, the better the adaptation in agriculture will be. And that's where I think I will stop. Thank you.
Thank you. Any questions?
Thank you to you for your presentation. It was quite informative. I just had a thought around the adjustments that our economy and our society would have to make over time when it came to our shift to a more conservation style of agriculture, more climate-smart style of agriculture. And you talked about rotation of crops, not necessarily going with the same crop that a farmer has gone with for decades or years. And in some ways, the way the system is currently, it allows us to have some certainty about what sort of products and foods we are going to have over time, or in any given year. So I was just wondering whether you could share on some of those adjustments that we might have to make, not having, I mean, maybe I'm not reading it correctly, but not having a certain product that we used to every single year, every single season, maybe, you know, exposing ourselves to different types of grains, those sort of things. You know, just a little bit more around
as the consumer.
As a consumer,
Okay.
as farmers,
Okay.
the economy generally. Of course, you know, the maize and those crops are linked to or can affect our exchange rate, for example. So there's macroeconomic consequences. And I was just wondering if you could share some insights on that, yeah.
And if I can add a little question to that, is there if we do these kinds of conservation agriculture approaches, is there a trade-off between volume and sustainability? Like, do these systems necessarily result in a drop in output? And then as well.
Thank you for the presentation. I just wanted to understand, how do we trigger a small water cycle when I'm trying to reconcile that with the idea that we're going to be drier and have less water. I mean, how do we link that together? Because I understand what you were saying about soil and the water systems, but in a future which is going to be drier, how does this virtuous cycle start?
Okay, I'm going to cut the questions there if you don't mind, and
Okay.
let you answer.
Right, the different crops. I might not be the best person to answer that. It's going to be difficult to predict that. I think the market will lead us to some extent. So what we're doing here is really still fitting into the market. So the cash crops are still the normal cash crops like maize, sunflower, soya. There's a lot of other initiatives outside the scope of my talk and the system that try to push new alternative crops like millet or so. But it's really from a person outside that sphere of market and crops and so on. It's really, I can see it's difficult to push a new crop into the market. But so where there's demand, and I think the consumers can also start to push the demand. What we are trying to do, that's a bit off this point, is to help consumers decide about the quality of the food that they have in the shop. So what we are trying to move towards is a scoring system where we go out to the farm and we score him based on soil health, water use efficiency, biodiversity, etc., etc. And based on that score, he will receive a certain score or a certain level. And that level and that label will be on the product. And the consumer, when he walks he or she walks into the market or the shop, will be able to watch that label and see that this farmer has produced this food from a very climate smart practice or farm in the Free State or in the KwaZulu-Natal or wherever. So that's where we want to move to give the consumer the choice to choose between climate smart food and other food. That's a bit off your point, but at least touching on that. But yeah, maybe we can discuss your question a bit further. Thank you. Drop in outputs? No, this system, especially over the medium to long term, is going to be, I would say, the only system that will be able to produce, giving in the light of climate change, temperature changes, rainfall changes, etc. If your soils are not correct, if your soils are not healthy, if your soils are not covered, you don't have resilience, you don't have less input costs, you will struggle, you will not survive. And we've seen now with these systems, with healthy soil, it's the only way you can sustain your production and increase your production. There's no way else. And it will also reduce your risk, it will increase your profitability, etc. So there's no question that this is the way in terms of production, especially in the future. Because we're losing, what's the alternative? We're losing our soils. We're losing our biodiversity. There's no alternative to this. Just need to open and educate farmers and transform them. Yeah, that's a good question. I think there's a lot of science still necessary here. We know the power of restoring the small water cycles, especially in smaller landscapes. But yes, the question is, what is the effect or the overriding effect of the climate change and the global climate change? And that is the type of research that we're really going to need to monitor and see what's going to happen. But it's not stopping us at all to implement and restore the small water cycle, because I believe definitely it has a huge effect on desertification, and we know that the desertification, what effect it has on weather, local weather. And I'm not going to go into detail right now, but that's an interesting discussion and underemphasized. What agriculture can do to restore the small water cycle, which includes rainfall, locally, landscape-wise.
Thanks very much. Thanks for
Thank you.
your input.